These next examples are going to be asking if one letter is a function of another letter. We have to be careful about always assuming x's are input and y's are output. It really just depends on the situation. So if I take a look at this example number 2, they're asking, is y a function of d? So my y is what's coming out, or my output, and the d is inside the function, that's my input. So let's think about this in terms of using some diagrams here. My input is the d, so for example, $2.50, $2.70. So I've got that one taken care of, that one taken care of, 240, -50, and 70. Now I'm not going to write 270 again in the pot because I already have it here. But in this grouping, go my output. My output were the y's. So I have 1982 through 1987. 92, I'm just going to write in 93, 94, 95, 96, 97. All right, so watch what happens. We kind of can tell what's going to happen here. At 250, that maps into 1992. 270 maps into 1993, but 270 also mapped into 1997. And here's where I can stop. I see one input mapping into two different output. So is y a function of d? The answer is no. And rather than say for every input there are two, or, I've got two output, therefore it's not, let's be a little bit more specific. For the dollar amount, 270, there are 2 years, and then be again specific, 1993 and 1997 associated with it. Since it's a word problem, use the words of the problem. We have y years, d dollars, rather than just say for every input there were two output. Well, I don't know what your input and output were, unless you tell me flat out what it was. So for my $2.70, which was my input, there are two output. But notice I'm being specific by what my input and output were. So the next part is d a function of y? Notice now d is on the outside, so that's my output. And y is inside the function, that's my input or independent variable. So now when I go draw this up, my input is the y, which are my years. So that again, 92 through 97. And then for my output, that's my d's, which are my dollar amounts. So again, you don't write down duplicates. Right, 270 would have duplicated. So now we can go ahead and do the mapping. 1992 went to 250, 93 went to 270, 94 to 240, 95 to -50, 96 to 70, and then 97 up to 270. For this one, for each input, there is exactly one output. But rather than say input, output, if someone's reading your work, they don't know what you mean by input, output. So use the letters or use the words associated with it. So for every y year, there is exactly $1 amount D, where our Y now is the input and the D is the output. So rather than use the generic definition, be specific. Use the variables that are involved in the problem. For the next example, we let D stand for the dosage in milligrams and W stand for the child's weight in kilograms. Then we have this formula, D equals 50W, gives the rule for finding the maximum daily drug dosage of ampicillin. So what are the logical choices for the independent and the dependent? Remember, the independent is the input. And according to my rule here, the input looks like if I know the weight, that's my input. So weight, and the variable is a letter. So the independent variable is W. The dependent is the output. All right, my output in this case is D, and that was my dosage. And we're looking for a variable, so the variable would be D. Does the equation represent a function? Well, one thing you could do is graph it on your calculator. Type in D or Y equals 50x, because we don't have D's and W's on graphing calculators, and look at the equation of it, see if it passes the vertical line test. But more importantly, since this is a word problem, think about it logically. If I have one weight, one input variable, am I going to have two different dosages? And the answer is no. For every weight, or for each weight, there is exactly one dose that you should be taking of medicine. All right, so for each weight W, there is exactly one dosage D, so it is a function.